All right, this is the third day of notes on naming organic molecules. All right, so you guys are going to love this. We got cycloalkanes, which means it's cyclical. It's an little circle, or typically a hexane or a square or triangle, whatever. So the name of the ring will start with cyclo if it's cyclical. Substituent groups are numbered, so the numbers sum to the lowest total possible. Cis or trans must be used at times. Typically, we're talking about isomers. All right, next page. Cycloalkane naming examples. Oh, there we go.
Oh, I failed geometry.
Yep, so that is a square, but if we're thinking line angle formula, each corner is a carbon. And if it's a secondary carbon, it has 2 hydrogens. Primary carbon has 3. Tertiary carbon has 1 hydrogen. So let's put this in another way. That's a lot to draw all this stuff. That's why line angle formula is way better.
Oh dear.
So there it is, but we got 4 carbons, so 4 carbons is?
A square.
It is a square. It's butane, so, but since it's cyclical, we're going to call it cyclobutane. The smallest cyclo would be a triangle, and that would be not butane, but propane. So we got cyclopropane. And then you can make a pentagon would be cyclopentane, hexagon, cyclohexane, and so on. All right. Hey, we got some more examples. We got a cyclobutane with 2 methyl groups coming out of it. So you got to have the lowest number. So you can't count here like 1, 2, 3. It wouldn't be 2, 3. The lowest number would be 1, 2. So it'd be 1, 2 dash. How many methyl? 2 dimethyl. Cyclobutane. 1, 2 dimethyl cyclobutane.
What the frick?
So let's do another simple one before we go to the halocycloalkanes. Let's do something tricky. There we go. So all sorts of stuff happening here. We got 2 methyls and 1 ethyl. Ethyl comes first alphabetically, but how do we name it? Would we name it 1, 2, 3 or 1, 2, 3? Yeah. 1.
Yes, Lydia. You are.
You know what? 1, 2, 3 equals 5, and 1 plus 2 plus 3 equals 5. So you were correct when you said 1, 2, 3.
I know.
Which means this has multiple names.
Both answers
Multiple.
were 1, 2, and 3.
Yeah. All right, so we'll just do this one as 1 ethyl. And I didn't give myself enough room. That's the danger of naming dimethyl. Should I do it that way? I don't know. Cyclopentane. All right. 1 ethyl 2, 3 dimethyl cyclopentane. But we could also name it as the methyl being 1. So, both names would be acceptable. If you Googled either one, Google image, it would give you this. All right, let's do this one. Here's a cyclohaloalkane. Because there's a halogen in there. This is 5 carbons, therefore it's cyclopentane. Cyclopentane. But we got chloro. chloro, since it's on the first carbon, you don't have to write 1 chloro, but if you really like writing number 1, you can. It could be 1 chloro, cyclopentane. All right. Oh, and then we got, is that an octagon or a hexagon? 1, 2, 3, 4, 5, 6. Hexagon. So hexane, cyclohexane. We'll write this here, cyclohexane, just in case we need the space. All right, so this is where that organic euchre game comes in, because we've got different functional groups that have different power. And in this case, halogen is going to have more power or be worth more than a methyl group. So we are going to, am I saying that right? No, I'm sorry. That's when we start getting ends. So in this case, it's still alphabetical order. So we got chloro and methyl, but in this case, it comes first. Oh, yeah, actually, no. In terms of, yeah, that's what I was thinking. In numbering it. So do we number it with methyl 1 or chloro 1? And in this case, because chloro trumps methyl, we're going to number chloro first. So that's where it comes in. So 1, 2, 3. So this is going to be 1 chloro, 2, 3. 3 methyl. And there's not supposed to be a space there. That just kind of happened. Sorry about that. Okay. 1 chloro, 3 methyl, cyclohexane. All right. Moving on to constitutional isomers. We kind of did this already. But this is referring to cycloalkanes now, constitutional isomers. So the rigid ring in a cyclic structure prevents rotation of substituents bonded to the ring. A cyclic structure with 2 substituents has 2 isomers called cis-trans isomers. So you got cis, where one is going up, the other is going down. No, that's trans. Trans is one is going up, the other going down, and cis, it's like a field goal, they're both going the same direction. All right, so cis isomer, I just said it, yeah, it has 2 substituents on the same side of the ring. Trans, 2 on opposite sides. So here we got cis, and there we got trans. So why don't we name cis or trans? How about this first one? Oh, there it is. Trans. How about this one? Cis. And then how about this one? Trans. This is huge in biochemistry, which we might get to after the IB exam. It'll be kind of like a bonus unit. Normally we're supposed to get into it, but they got rid of paper 3 this year, which is good. Hopefully they get rid of it next year too, because they're behind those juniors. I know, but they're behind like all units. Like they haven't done anything for their IA, so they're behind. So, it being a 2-year program and it being disturbed this year with COVID, hopefully they modify it again next year. All right. So we'll talk about this a little bit after the IB exam, but this is a sugar, and depending upon whether it's cis or trans, is going to determine whether it's an artificial sweetener or a non-artificial sweetener. Yeah.
How did you tell the difference between the second and third one being cis and trans?
Oh, so this one, the chlorines are both going up, where here the bromine's going up and down, up and down. No.
I was looking at the lines.
I was also looking at the
Yeah,
line.
Oh, no.
lines, and I was like,
It's all about the electronegative or the functional groups. All right.
well, yeah, like one line is folded, so
Guys, we've graduated to the 2nd chapter of this unit. So.
No! When's the test?
It'll say it. In the words, it'll say it. Otherwise, you win. No.
You have a cycloalkane with like connections to alkanes.
Yes.
And then which one do you do first? The cyclo or the allo?
You do the longest chain. You're not gonna have to name stuff unless it's like a phenol, and then like, okay, just fun fact. So this is phenol, and it's a common organic molecule. That's why they name it just phenol. It's a benzene ring with an alcohol coming off. But phenol is written as phenol. OL is all. That's, I think, here, yeah, functional groups. We're going to get into alcohols next after alkenes and alkynes. But if it's connected like this, and let's say it's something like this, this is now going to be called an alkyl group, and it's going to be phenyl. This isn't really in IB. We do talk about it a little bit, but you're not going to be asked stuff like that. But since you're asking, I'll answer it. So how do we name this? This is 1, 2, 3, 4. So that's butane. So it'd be like phenylbutane.
Okay.
So how would you count something like that? Because you said butane, but I would look at that and I would say that's a pentane and a hexane.
So knowing your organic chemical reactions, that's and you don't know anything about organic chemical reactions yet. So how? Let's say this is the product. I can draw it like this because we'll talk about benzene rings. They're not double bonds. They're like partial bonds, and a better way to describe it is like a blur. So, or if you want to do that, you can do that. So.
Is it like that thing like where we had like there's three like sections and then there's like the dotted dashed lines?
Kind of like that. Yep. So it's oh my gosh, resonance. All right. So basically, these would be the two reactants, and
Oh, I see how it goes on to the OH part.
yeah. So this isn't the correct pathway, but there's this, and then there's stuff that happens here to create this. So, we're going to be dealing with simple. What was that?
I'm just not going to worry about that.
Don't worry about that yet. We'll deal with a few simple types of reactions.
Tell us what square is again.
A square. All right. Well, a square is.
Wow.
All right. But are we going to get to some of this type of stuff, like the baby stuff, organic wise? Yes, we are. So. All right. So. Okay. So isomers. Who can say what isomers are?
Substances with the same molecular formula with different structural formulas.
It's
All right.
an isomer.
You guys both got it. So it is a molecule that has the same molecular formula but different structural shape and formula. You got it. All right. Structural isomers are just a different arrangement. So kind of like this. These two are isomers. All right. Unsaturated hydrocarbons. We were talking about saturated hydrocarbons, which means they're totally covered with hydrogen. But what if you have unsaturated? That means you have double bonds or triple bonds that are present. That means not all of the bonds are available for hydrogen because they're used up in double or triple bonds. So that's what we call an alkene, something with a double bond. And an alkyne is what we call a triple bond. So usually when we work with those, people have all kinds of trouble. So we're going to have to practice it.
Wait, so then an alkane is a single bond?
Alkane is a single
Oh,
bond.
so it's just AEI, like the
Yeah.
vowels, and it just goes in order.
Yeah, ane, ene, ein.
AEI.
Yeah.
Is it
Uh,
definitely going to be on part
Is
one?
there an alcohol?
What's that?
Is it definitely going to be on part one?
It's going to be on single bonds, double bonds. It's alkanes, alkenes, alkynes. That's why we're going to do it on Tuesday. So. All right. All carbon chains end in ene if it's a double bond. Always number the double bonds first. That's your functional group. So a double bond trumps a single bond. That's what is numbered first. Diene is used if you have two double bonds. Triene is 4. I guess if you had, triene is 3. If you had 4, it would be tetraene, and so on. Cis-trans configurations must be utilized. All right. Name the parent hydrocarbon by locating the longest carbon chain that contains the double bond. So key word, contains the double bond. So the longest carbon chain is not 1, 2, 3, 4, 5, 6. Can't be. It's got to hold the the functional group that's trumping everything. Oh my gosh. Sorry about that. Oh. 1, 2, 3, 4, 5, 6 you would think is the longest chain.
It's not.
It's not because it doesn't have that double bond in it. So we got 1, 2, 3, 4 or 1, 2, 3, 4, 5. I'm thinking the 5. So this is not pentane. It's pentene. Pentene. Because there's a double bond in there. Couple ways we can write it. It's either 1, 2, 3, 4 or 1, 2, 3. No, I'm reading this wrong. Let me circle this. That's the main chain. All right. So it's either 1, 2, 3, 4 or it's 1, 2. We're going to go with 2. And that's an ethyl group. 2-ethyl pentene. Could you name it this way as well? Yes, you can. 2-ethyl pent. Oh no, that's on the. Oh yeah, it's on the 1. You could do that as well. 2-ethyl pentone. Or since it's the first carbon, you can just do 2-ethyl pentene. Another way of writing it would be 2-ethyl 1-pentene. So there's a lot of different ways. Let me write that one down.
So the second number is just referring to how many double bonds exist.
No. The number of double bonds is determined by, it would be diene.
Oh.
So it would be pentadiene. If you had 2 double
If
bonds.
there was another one connected to the double bonded one, so then it would be like hexene or whatever, but it would be 2-ethyl pens or hex 1-ene.
Mm-hmm. Yeah,
Wait, 2-ene? It would be 2-ene then?
Another double bond.
like right here.
Oh, another single bond. Like a single bond.
Oh, it would be 2-ene. Yep.
Okay.
Yep. So here's another one. We got 1, 2, 3, 4, 5. What? It's the same thing. Does not contain. What? Oh, that's the same thing. I'm not sure what they're trying to do
I
there.
think no. I think because it's looking at like this one is looking at this and this one's looking at this.
Yeah, hexene. 1, 2, 3, 4, 5, 6. Yeah, it's not hexene.
Yeah.
Got it. All right. Name the alkane. Do you want? Let's do some of these together. Is that all right? Or okay.
I guess.
Okay. So longest chain is 1, 2, 3, 4, 5, 6. So we got hexene. And it's 1, 2, 3, or is it 1, 2, 3?
1, 2, 3.
Yeah. Could accidentally get that one right. All right. So it's 3-hexene. But before we do that, we've got 1, 2, or is it 1, 2, 3, 4, 5? 1, 2. All right. So it's 2-methyl. And we're at 1, 2, 3. And you do it where the double bond starts, which is the 3rd carbon. 2-methyl 3-hexene. And we're good to go. You could do 2-methyl hex 3-ene. Oh, here we got 2 double bonds. Because the double bond starts on the 3rd carbon. So here we got 1. It starts on the 1st, 2nd, and then on the 3rd, 4th, 5th. Or we could say it starts on the 2nd, and no, we want to count left to right because it's smaller numbers. It's 1, 2, 3, 4, 5, pentene. There you go. 1, 3, pentadiene. 1, 3, pentadiene. Homework. Let's see.
I got yelled at by an office lady today for having the pillow. What? So they use it.
Oh, did you tell her you just had
The next page.
Yeah, and she was like, I guess I'll make an exception. And I was like,
Oh, I dare you to not.
I would have smacked her with the pillow. Not yours.
All right. All right, guys, we're almost done. What is it, 25 after?
Yeah, 5 minutes.
Oh, 20 after. Okay. All right, guys, we got a little bit more time. We got alkenes, conjugated versus unconjugated. So this is terminology. in biochem, we talk about the various conjugation in relation to pigments and why it causes colors and all that. So conjugation just means we got double bond, single bond, double bond, single bond. If it's unconjugated, you don't have a syncopated, you don't have a pattern. It's just kind of random. The double bonds are randomly placed. Conjugation, there's a pattern. Wax on, wax off, wax on, wax off type thing. And this definitely has an impact on colors and all of that stuff. All right, cycloalkane practice. Ooh, no, that's not cycloalkane, that's cycloalkene. Typo. All right. All right, so we want to start. We could either start 1, 2, 3, 4, 5, or 1. Well, looking at it, let me redraw this to show where the numbers could be also. So we could count it as, so basically we got to count the 1 at the double bond. So that's going to be like right here. Why am I putting it there and not there? Well, because we want methyl to be a low number 2. We don't want it to be 2. We want it to be 1. And actually, yeah, that would explain really why we got to count it this way. So that this can be the lowest one, but then you got to follow through on your double bond. So you got to count 1, 2 that way. That'd be the reason. Tricky. Well, let's try that. 1, 2, 3, 4. Here. 1 and then 2, 3, 4, 5. So it'd be 2 and 3 as a. Oh yeah, 5, 6.
But you don't count the 1 at the bottom. So
Yeah, but you have to because that's where the double bond starts.
Yeah, but it's on the last one. Isn't the first one 8?
Yeah.
1 and 5, and then on the next one you have 1, 2, and 3.
oh yeah, the first one is 8.
Well, let's name it like this. Well, let's name it like this. All right. So we got 2, 3. This would be 2, 3 dimethyl cyclopentane, and or this one would be 1, 5 dimethyl cyclopentane. All right, let's look this one up. See what Google says. Maybe it's a 2 answer. Well, DuckDuckGo. I'm a DuckDuckGo guy, so 2.
Just knock off Google, you don't get as many search results. But it
Mr. Weaver, you use DuckDuckGo?
Yeah,
What is it?
it's a search engine.
But it doesn't take the information. It's like
I'm economically protesting this one against big tech. All right.
that's like my mom.
There's